So this week we're going to be talking about functions, and we're going to be writing our own functions. Functions are really important in modern programming because it allows us to organize large amounts of code. For example, an application like Microsoft Word is millions of lines of code. If it was just start at the top and go to the bottom, and anytime you had to make a change, you had to figure out where it was and where every piece of the code was affected by this particular change, it would be completely unmanageable. So functions allow us to basically separate our code into little chunks, into little blocks that then we're able to, when we need to make changes, you can just make the change to one particular function. And as long as you don't really change the functionality of how the function works, you just change the internal part, you don't actually have to change other pieces, or maybe you only have to change a few pieces that have dependencies. So each function we want to create as is sort of its own little black box. We want anyone who uses the function to not need to know what goes on inside. We don't need to know what the code is inside of the black box. We just need to know two things. We need to know what sort of inputs it needs, and we need to know what is the output of this particular function. So a function can take no inputs, it can take one input, and it can also take multiple inputs. So it may not take any input at all. It could just take one input, or it could take multiple inputs. We usually call those arguments or parameters, depending on whether or not you're talking about a function that belongs to a class or a function that's on its own. Classes are a part of object-oriented programming. Python is capable of object-oriented programming, although we won't be learning it in this class. It is a capability that Python does have. So in addition to knowing the inputs that a function needs, you also need to know what the output is. Now, you don't have to have any output in a Python function. However, if you don't have any return, any output, the default is the special value none. It's not the string none. It's its own special value that means null. It means there is no value in the return. It's just the none value. So if you see a bunch of nones start popping up in your code, it's because you're trying to print a function that doesn't return anything, and so it's just printing none. So look out for that. The important thing to know about the inputs and outputs of a function is what data type is required, what data type do you get back. So is this value that you're giving to the function, does it need to be a string? Does it have to be a number? If there's more than one, what data types do those have to be? Because the function will only work if you give it values that are of the correct data type required by that function. And similarly, we want to know what data type the output is going to be, because you want to be able to use that. So if you're going to get a string output from your function, of course, that will be used differently than a numerical output from your function. So let's take a look at some functions that we already know about and how they work in terms of inputs and outputs. So we've been using the print function. Print is the name of the function. We do all lowercase letters. When we create our own functions, when we name our own functions, we want to use the same rules that we use for naming variables. What these parentheses, every function, whenever you call a function, must have these parentheses. Even if you don't send it anything, you still have to have the parentheses. So the way the print function works is there's multiple versions of the print function. You can call print with nothing in it. And the output of print is actually a special output. It's just output to the screen. So it's not really any particular data type. It is a function that interacts with your system to actually output letters in the shell on your screen. So otherwise, the print function in Python usually takes a string, and we can add, as many of those strings together, concatenate as many of those strings together to create one big string in the print function that will print to the screen. Or if we want to have multiple data types as parameters in the print function, we would have to do something like, I 54, the letter E, and 1. We could actually put these. So these are all separate arguments that are going into the print function, and they're separated by commas. And this is true in all functions. When you have multiple arguments, multiple parameters, you're going to separate them by commas. That's why we can use the commas in the print function to separate variables or separate pieces of data of different data types when we send them to the print function. The print function doesn't have any output. If you try to print a print function, you'll get none or you'll get an error. So either way, we don't print functions. We don't print calls to the print function. So you should never have something like this: print, whatever. No. We also will never have something like printing the input function, right? Like this. Also no. We just print data types, basic data types separated by strings, or we print strings concatenated together, or we can print other function calls if they return a string or a number or a Boolean or a list or some sort of value that we can actually print to the screen. The print function will sort of work with an input, but it's going to give you all sorts of errors because input does return a string. So it's going to print the prompt, it's going to get your value, it's going to return it, and it's going to print it, but that's usually not what you want to do. You actually want to save that string into some sort of variable for you to use. So this is really you won't really ever have any reason to print the value of a call to the input function. All right, so taking a look at inputs, that's another function that we know how to use, input. You can leave this blank. Of course, the user won't really know what to do. What we usually put in here, what we have to put in here is a string, one string only, and it's basically a prompt that tells the user what to do. Enter a name, right? So that could be what we have inside. So that's what we would be sending to the input function. And the input function actually does return a value. It returns a string. So we might save it into a variable called string1. And going back to our idea of a function as a box, right? Let's see what this looks like for the input function. For the input function, we're going to input a string. There's some code in here. We don't care what it does, but at the end, what happens is we get the output of a string. We get a string returned to us. We can save that into a variable and then be able to do further processing on that. The print function is another built-in function that we've used already. The print function can take a string, or it can take a number. It can take, that would be an int or a float. There's no num data type. It could take a bool. It can take different data types. What it does is it actually doesn't give any outputs in terms of what we think of as output. Instead, this is a special function that interacts with the system to print to the screen. So other than that, there's really not an input or an output, the way that we think of output. It's really printing it to the screen. It's not returning something to our program. So these are two examples of built-in functions, and we'll look at some other built-in functions as we also start to write our own functions. So some other functions that we've used is part of the Turtle library, and when functions are a part of a class, part of a libraries are often classes. When a function is part of a library or a class, we call those methods. So you may see that kind of terminology in books or other resources. So functions and methods are very similar. A function is sort of standalone, and a method is a function that belongs to a class. So for instance, we've really looked at 3 different modules. We've looked at random, we've looked at turtle, and we've looked at math. And all of the functions inside of these libraries are, we would call methods, and often the way you will see a method is a method has to be used with an object. So we import all of these, and then after we import them, then we can use their methods. So for instance, we might try to get our num by calling random dot rand int, and we have to send it 2 different parameters. We have to send it a beginning value and an ending value. So in this case, the rand int method that is a part of the random class, the random library, is going to output the return a number between 1 and 10. So our function sort of looks like this. This is our rand int functions. Our input is 2 integers, right? A starting integer and an ending integer. And the output is also going to be an integer, and it's going to be an integer between the starting and ending point, inclusive of the starting and ending point. So the randint function takes 2 integers, and it returns an integer that falls in between those. So some of our math methods, for instance, so we have the square root function that is a part of math. So we might have, some variable is equal to math dot square root. You've also always got to have parentheses. In this case, you're going to send it a number, and it could be an integer or it can be a float that you're going to take the square root of. So if we were going to give it 9, it would return 3. So if we take a look at our function as we're imagining it, we don't worry about what the code does because it's already been implemented for us. We're going to input a number, an integer or a float, and it is going to return us an integer or a float, whatever is appropriate. That is the calculation of what the square root is of the value that you put into it. Turtle, for instance, once we've imported turtle, we may do something like call turtle dot fill color. And in this case, we're going to send it a string. In this case, well, let's send it blue. So this is what this looks like. We're going to input fill color with a string that represents a color, and there is no output. It actually just does something behind the scenes, which is really setting a variable that is the fill color inside of that class. So we don't have any output of this. Nothing gets returned to the program itself from the turtle.fillColor method. And a lot of turtle methods are like that. For instance, we have different kinds of ways to set the color. We're going to move it forward, we're going to turn it, we're going to set a heading. It doesn't need to respond to the program. It just does something on our turtle screen, versus something like the x-core and y-core coordinates. If we call, we might call this y turtle dot y core, and we don't have to send this anything. What it does is it just returns us the current y coordinate where our turtle is on the screen. So in this case, we're not going to send it anything. It's just going to give us probably a float value that tells us currently right now, if your turtle is right here, this is some sort of positive y value, less than the maximum value allowed on the screen. So it actually returns you a float on the screen. So there's some other examples of built-in functions that we've been using, and we're going to continue to learn more of these built-in functions, use more of them. We're going to use a lot of string methods. We're going to use list methods. These are all built-in functions that are a part of Python that we're going to use. But we are also going to learn how to write our own functions. So whenever we're writing a function, we need to determine what we're going to call it. So you need a name for your function. We need to figure out what we're going to send it. So what sort of parameters do we need? We need how many, and we need what data types these are going to be. And then we need to know if we have any return values, and if so, what data types are those going to be. So let's say we were just going to write a small function that is going to say it's going to take two numbers and add them together and return it. So a good name for such a function might be, add 2, because it adds two numbers together. So it's going to take two numbers. Most likely these are probably going to be floats, unless it will also take integers, though. We're going to make sure it works for both of these. Python's very flexible that way. Other languages are not. Other languages, you generally have to specify in the function definition which data type, and you'll receive an error if you don't send it that data type. We do not have to specify data type in Python. We just have to ensure that it's going to work for the data types that we want to send it. And as we'll see in this case, the way we write this function will actually work for strings as well. So the return data type, if we want to add two numbers, we need to make sure that it can handle returning us, floats and ints. And just because of the way Python works, this will also work for strings too. But when we're writing our own functions, we have to use the def keyword. Then we're going to name the function, add 2, and then we're going to have our parentheses, and we're going to specify the variable names for our parameters. We're going to have two parameters in this case, and we're going to call them n1 and n2. We put a colon. This tells Python that we're done with our function header, and we need to indent 4 spaces. So this is right here is about 4 spaces. Python is a space delimited language, which means that the spaces are very important. They help the Python interpreter actually figure out what things mean. So this colon says our function header is done, and these 4 spaces says this line belongs to this function. If we didn't put these 4 spaces in, we'd get an error because we have a function header with no code in it. So anything that is out 4 spaces that's lined up with this D is going to be seen as not belonging to this function. So anything we want inside the function has to go 4 spaces indented in. So we're going to add two numbers. So let's say our total is going to be equal to n1 plus n2. And then now we want to return that T value from this function. It's still indented 4 spaces because it still belongs in this function, and once this function runs, it's going to start here. It's going to when you first run it, it will store this function in memory. It doesn't actually run until you call the add to function. So when you run this definition is stored in memory, and along with this code. So now if I want to actually call this function, I have to call it outside of the function. So I'm going to say something like my total is going to be equal to, I'm calling add to, just like I would call the input function, just like I would call the print function, just like I'm calling random.random. I'm gonna call this, and I could have variables, if I had values stored in them, but I can also just send numbers. So I could send 54 and 2.0, and when this runs, it's going to actually add 54 and 2.0 together, so you're going to get 56.0, and it's going to store that in total. So that is just kind of our first look at how to write a function. We're going to practice writing a whole bunch of these and calling these and seeing how they work. Remember, with programming, the only way to really learn how to program is to practice a lot. All right. So let's practice writing some functions. So let's write the function we just wrote, but we're going to type it into idle. So we're going to say def We'll call it add2. It's going to take a variable called n1 and a variable called n2, and then we're just going to have a variable called total, and that's going to be equal to n1 plus n2. And then from this function, we're going to return t. Now in Python, we can write code outside of functions, but that is really bad practice. So that makes your code very disorganized. So from this point on, we want all of our code to be inside of a function with the exception of import statements and the exception of comments. So I can have all your import statements should go at the top. So I'm just going to put an import statement up here so we can see what that looks like. And then everything else we do is going to be inside of a function. So if I want to test this function, this is called a helper function, and basically we're going to use the convention of having a main function and helper functions. So I'm going to create a main function. I never send any parameters to main. Here is where I'm going to do, you can think of this as the place where your program starts. So main is always going to be the first thing to run, and to make that happen, the last thing I'm going to do is just make a call to main. So what's going to happen is when this program runs, and here let's go ahead and put in a call here. So I'm going to say I've got a total, and that is going to be equal to, I'm going to call add2, and I'm going to send it 54 and 2.0, and then we're going to run this and talk about what's going on in this code. So let's move this over so we can see the shell, and let's run this. Check for any syntax errors or problems. So it looks like we were good. So this is going to return t right here. So that's what returned here. So we also have to add a print statement. But let me walk you through what's going on here. So here I have my comments up at the beginning. So this just, our standard name, when was this written, some sort of basics about what's going on here. Have all our import statements at the top, and then I like to put my helper functions before main. In Python you don't have to though, however, because we don't make a call to main until the end. You could have main first and then all your helper functions. I think it's a little bit more organized to have all my helper functions together, so I'm going to create a little section called helper functions. And this function here, we're going to put a comment for each of our functions so that we know what our function actually does. So this function takes two numbers and returns their sum. And I'm going to show you this will actually work for strings as well, but my whole point of this was to be able to take two numbers. So this is what I want this function to do. When this program runs, the interpreter is going to come up here, ignore these three comments. It's going to import the random module so that I can use anything from random that I would like. It's going to ignore these two comments, and it's going to take this function and store it in memory. It's going to create a space called add2 that actually points to the place where all of this is stored. I'm going to have a place for this n1 variable, a place for this n2 variable, and a place for this t variable. The important thing to know about this is that these variables only exist while this function is running. So when we get down here to main has no idea what n1 is. It has no idea what t is. It has no idea what n2 is. Similarly, whenever I run this add2 function, it has no idea what total is. So we have to make sure that we are using variables appropriately, and we call this scoping. So everything that exists inside of this function only exists inside of this function, and this is called local scoping. Everything that exists in this function only exists inside of this function, locally scoped. We can declare global variables outside of a function, and there are some reasons to do that, but there aren't very many. So for the most part, we will not be using global variables in this class. Your replets shouldn't work with global variables. Do not turn any assignments in with global variables. It's not that there's never a reason to use global variables. There absolutely is reasons to use global variables, but none of those will apply in this class. So you'll learn learn more about global variables and their uses when you get to object-oriented programming, and you'll also learn about the security issues that exist when you choose to use global variables. So once this function here add2 is stored in memory, we've got a space for n1, a space for n2, and a space for t. It's going to come down here and it's going to create some space in RAM for main. So it's going to create a location. It's going to put in here total, and it's going to put in, all the code goes in with the function definition. Then we're going to get to main. This call to main is what is actually going to get our program running. So once main actually gets called, the very first thing that happens is we're going to jump up here to main, and we're going to say, okay, we want to create this variable. Wherever this variable is created called total in main, we want to actually call this helper function with these two parameters, and whatever gets returned from this function is going to be stored in total. So we call the function, so we actually jump up and we're going to run this code. So 54 gets stored in the local variable n1, 2.0 gets stored in the local variable n2. We're going to add 54 and 2.0 together. That's going to be 56.0, and then we're going to return that, and that's going to get saved into total. So nothing comes out on the screen yet because we haven't printed anything to the screen. So we're going to add this line to actually print total to the screen so we can see what actually happened. So let's run this again, and we're going to get 56.0. If I change these, let's change this to 59.1, and let's change this to 12. We can run this, and we're going to see now we're going to get 71.1. If I try to print t, this is going to give us an error. Main does not know that t exists. So I'm going to run this, and I'm going to get an error, name error. T is not defined. That's because in main, t is not defined. Main has no idea what t is. Main has total, it doesn't have any t, doesn't have any n1 and n2, has no way of getting to those variables. So print total. All right, so similarly, let's say we're going to get input from the user to send to this add2 function so that the user can give it however many numbers, whatever values of numbers they want to give it. So let's say we've got num1 is going to be equal to float input enter first number. Num2 is going to be equal to float input enter second number. And it's always good practice to let the user know what they're doing in the first place. So we should print some sort of welcome to the add to numbers, or we can not even say welcome. We could just say this program adds two numbers together, right? Because your user, I have access to your code, and really I'm your user, but in the real world, your users don't have access to your code, so all they see is actually what prints out on the shell. So we have to be cognizant of that. We should just get into the habit of that. So here we go. So here's a good error that I just made. This is a nice logic error for you to take a look at. So I'm going to enter two numbers, 2 and 3, and I get 71.1. Why is that? Because I'm still sending 59.1 and 12 to the function. I actually have to make the change to send not those two particular values, but instead send the variables where my user input is stored. So now instead of sending those two hard-coded numbers, I have whatever the user inputs from the keyboard will be saved into these two variables, and then those two values will be what is sent to the add2 function and then printed. So let's print that. Right. Now it tells us this function adds two numbers together. enter the first number, say 4.0, enter the second number, 200, and we've got 204. So now we can tell the users what's going on, they can give us two numbers, and we can add any two numbers together that they give us using this nice little helper function. Again, what's really nice about this is, let's say I wanted to change this. Let's say we're going to add three numbers together now. I can either, keep this function and create a new one. That's what I'm going to do. Or I could just modify that one if I know I didn't need it anymore. But we're going to go ahead and change. So now this one is going to take three numbers and add it together. And now depends on what we want to do. If we want to allow our user to get three numbers, to give us three numbers to add together, then we can use our add. We want to change this. We don't want these to have the same names. There is something when we talk about object-oriented programming in the next course, you can use the same name for two functions if they have different numbers of parameters. We call this overloading. So you can actually have the same function take different numbers of parameters. And that's essentially what happens with the print function. We know that you can either give it one string parameter, or you could give it multiple, a string, an integer, a float, all separated by commas. So this means that that print function is actually overloaded. So now we have these two different functions, so we could add a third input, num3 is equal to float input enter third number, and let's say this time we're just going to use our add 3 function. So we're going to change this to add 3. We're going to send it all three numbers, and we're going to print total. All right. Enter the first number, 45 to 1.0, and we're going to get 50.0, which is actually incorrect, isn't it? 42, that should be 48. What did we do here? So I have a logic error. So this is a great way to think about how we debug. You run it with some different values, and I noticed here 45 plus 2 plus 1 should be 48, not, 50, which is what we're getting here. And the reason why we did is I just added the number 3 instead of the variable n3, which in this case would give you, instead of adding 1 to that third, it just added 3 to this. So 45 plus 2 plus 3 is 50. So I need to change this so it's not adding the number 3, instead it's adding the variable n3, and this should work the way it's supposed to. All right, so we've got 200, 1.2, and 9, and 210.2. That is the correct answer. So you always want to try multiple different values and make sure you're getting what you think you're supposed to be getting, so that you can identify any logic errors. And then just to point out, because of the way that Python works, and we can concatenate strings together like this, and we don't have to specify what data type our parameters are going to be for our functions, we can actually use strings for this. So I could say let's see, actually we can't, because we converted this to a float. So if we didn't have this part here in main, this function will actually work just fine. Let me see, I can show you how that would work by commenting this out. So let's do this. We're going to comment this out. So now if I just make a call to the add 3 function, so if I say total is equal to add 3, and I'm just going to send it 3 strings as if I inputted them from the user without casting it to a float, and I said I like and ice cream, and apparently I'm yelling because I'm using all capital letters here, and it's not going to I've got to print that. So let's print total. Nothing will come out to the screen unless you actually print it. So here we go. I like ice cream, and this is concatenating. So I'm actually concatenating here so it doesn't put any spaces in there for me. So you can see what happens. We get everything all concatenated together, all three strings, with no spaces in between.